A non-uniform rod AB has length 3 meters and mass 4.5 kilograms. The rod rests in equilibrium in a horizontal position on two smooth supports at P and at Q, where AP is equal to 0.8 and QB is equal to 0.6 meters, as shown in figure 1. The center of mass of the rod is at G. Given that the magnitude of the reaction of the support at P on the rod is twice the magnitude of the reaction of the support at Q on the rod, find the magnitude of the reaction of the support at Q on the rod and the distance AG. So that's the question then. I've got it in summary form here. So let's have a little look at it. Okay, first of all, the weight of the rod acts through G, we're told, which is here, which we don't know where it is. It's 4.5 kilograms, so this is a force acting down of 4.5 G. We're also told the reaction at P, so this upwards reaction force here, acting perpendicular, is twice, so let's call this 2R. And the reaction force at Q, which is twice the amount of here, we can label as R. So there's the forces acting then. Okay, and we can also label this distance here from A to G while we're at it to be a distance X. Okay, that's good. So let's just look at the forces then vertically. So resolving the forces vertically and applying it F equals ma gives, there's no acceleration, it's in equilibrium, so the resultant force will be 0. So 2R plus R minus the downwards force, 4.5 G, must equal 0. So that tells us then that 3R is equal to 4.5 G. And that tells us then that R is equal to 4.5 over 3 is 3 over 2, which is 1.5. Lots of G. So there's R, 1.5 G newtons. Okay, the distance AG. So the reaction at P, find the magnitude of the reaction at Q, which we've done because that's the value R. The distance AG, so let's take moments about A. So moments about A then, let's take them anti-clockwise, gives. Okay, so what have we got then? We've got 2R times 0.8 plus we've got R times 3 minus 0.6, which will be 2.4, won't it? So it's 3 R times 2.4. So that's that force, the moment of that force. 3 minus 0.6 is 2.4, and that's the distance here. So the moment will be R times 2.4. Minus, because it's in the other direction, 4.5 G times X. Minus 4.5 G times the distance X equals 0, because it's in equilibrium. So we've got 3R, oh, we've got 2R here. R is 1.5 G. So it's 1.5 G. 2 of these is 1.6 plus 2.4. So 2 of those is 1.6 plus another 2.4 is 4. And we can put the R outside there because it's common. Equals, and then we can move this over, can't we? 4.5 G. Lots of X. The G's cancel. So X is equal to then, read from right to left. It will be 6 over 4.5. And that's equal to 1 1/3, isn't it? Tap it in the calculator if you need to. 1 1/3. So let's just write that correctly. Meters. So there's our distance X, and we found part B, the distance AG on the diagram, which we labelled X. So there's our answer.